Okay, I think now it's recording. Okay, perfect. All right, so yeah, I was saying, guys, so we discussed, just to remind you, so last week we discussed, different kind of averages, right? We discussed the first, the mode, right? To the median, and three, the mean. Okay. So the mode, median, mean, guys, are supposed to be averages. And an average, what do I mean by average? An average, it's a number which describes, the data set or the data values. Anyway, yeah, any question? Okay. Anyway, so yeah, sometimes, in a data values or a data set, you will find like some values which are different from others. And then, in that case, actually, sometimes it's better to use what the trimmed mean instead of the mean. So, yeah, so today I'm gonna first talk about the trimmed. So today, so I'm gonna discuss. So we're gonna discuss first the trimmed mean. Okay, and number two, the weighted average. Yeah, so yes, let's start with the trimmed mean. Okay, so first, the trimmed mean. Okay, so yeah, as I said, sometimes in data values you can find like some value, a value which is very, very different from the others, the other values, right? Like in the homework number one, in the problem number two, we have this the salary of the CEO, right? And the salary of the CEO, of course, is much more higher than the salary of the other employees, right? So sometimes it's better to to remove some values from some exceptional values from the data set to have a mean which is a better representative of the data set. So so let me just first define the trimmed mean. So what's a trimmed mean? So this is the mean of the data. So a trimmed mean is the mean of the data or data values left of the data values left after let's say trimming a percentage of the smallest and largest values of the data set. Trimming a percentage of the smallest and largest values of the data set. So usually this percentage is actually 5%. So usually the percentage is 5%. Usually the percentage is 5%. All right, so before the example, let me just explain the idea again, guys. So let's say you have some data values. So the idea is the following. So let's say you have the following data values. So we have, all right, so we have, you know, the following. Data values. Okay, so for example, let's say the smallest one is 30, and then the next one, let's say it's, you know, for example, I don't know, let's say 70, and then like you have like 71, you know, 71, etc. And then, you know, you have numbers that are very close to 70, let's say here you have like 80, and then, you know, etc. But then at the end, you have like a very large number. So let's say, for example, 250, okay? So the idea here is that, so as you can see, like in the data set, so these data values right here, they are kind of close, you know, 70, 71, etc., 80, they are very close to each other. So close. Okay. But then you have this number, which is 250, which is this one here. It's very, very different from the other numbers or the other values, right? This is very different from the other values. Very different from the other values, right? Now, the thing is, so when you compute the mean of these data values, of course, you're going to take into account the 250, right? I mean, because 250, it's in your data set, right? So, so when you compute the mean, in this case, so then the thing is, your mean, it's not really good representative of this data set because of this number here, because of this 250, for example, which is very, I mean, which is very large number compared to the other ones, right? Compared to the 70 or 80, etc., right? So the mean in this case, if you compute the mean, was supposed to be like, you know, like 30 plus 70 plus 71 plus etc., right? And then plus the 250 over, of course, the size of the sample. So the thing is, the idea here is that this number, this mean here, it's not really good representative of the data set, okay? Because of this 250, which is very different from the other numbers, right? So, so this number here, we get, it's not, this is not a good representative of the data set. Of the data set. Okay, because, you know, because we include this 250 in our computations, right? So let's say this 250 is like the salary of the CEO, right? Which is much, very, I mean, a very large salary, right? Compared to the salary of the other employees, right? So the idea is to get rid of this 250 and to compute like the mean of the data set left after removing this number here, this 250, right? So the idea is now to remove the 250, let's say, and compute the mean of the new data set, and compute the mean of the data set left after removing the 250, let's say, the mean of the new the new data set. Okay, so this number, so this like this mean or the average salary of the employees, right, will be a better representative of the than the previous mean, right? Because in the previous mean we included the salary of the CEO, which is very high salary, right? So now when you remove the salary of the CEO, you get the mean or average of salary, which is a better representative of the data set, right? Or the better representative of the salary in the company, right? So this is a better representative of the data set or data values. Okay, so that's the idea. So the idea is to remove the extreme values, right? The values that are very different from the other values in the data set. All right, now let me show you with an example how this works. How we compute the trimmed mean? Okay, so well, basically, I think there are like 2 or 3 steps to compute the trimmed mean. Okay, so to compute the trimmed mean, so first we need to order the data values. So first, step 1, in the first step, we need to order data values or the data set data values. Okay, and the step number 2. So we need to first compute 5% of the size of the sample. So we need to compute 5% of the size of the sample. So this 5% represent like so what we are saying here is like, we are saying like the 5% of the data values are, they are kind of exceptional in the sense they are actually very different from the other values. Okay, so we compute 5% of the size of the sample, and then we have to remove, or we have to get rid of and remove or delete, remove top and bottom, remove from the top and the bottom 5% of the values. Okay, and then so after removing 5% of the top and the bottom, in the last step we need to compute the new mean, of course. So we need to step number 3. So we need to compute the new mean. So that will be our training mean. Okay. Okay, so let me show you with an example how this works. So example. So so in this example, let's say so the data represents, so the following data, so the data represents actually a random sample represents a random sample of winter, it's a wolf packs size in, let's say, in different regions in Russia or in the US, and different regions in Russia. All right, so let's say we have the following data. So in the first region, let's say in the first region, the size of the pack is, let's say it's 2. Then we have, let's say 2, and then 3, 4, let's say 5, 7. Next region, we have also 7, 8. Then we have, let's say 13. So here, this is 15. This is 2, 10, then 3, 4, 4, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 7, and then it's a 7, and then 8. Okay. So this is our data values. And so we need to compute, so the question is to compute the trimmed mean, and as a percentage, we're going to use 5%, using 5% as a percentage. Okay. All right. So so first step, this is like for the median, we have to order the data values. So first step 1. So I'm gonna order. So order the data value. So the smallest, we're gonna start from the smallest data value. Data values. So the smallest data value, of course, would be 2, right? So how many 2s? We have like 3 2s, right? I'm gonna just use so 1, 2, 3. So we have 3 2s. Okay, and then next we have 3. How many 3s? We have like 1, 2 3s, right? So 2 3s, 4s. How many 4s? So we have 3 4s, right? So this is 1, 2, and 3. All right. So there are 3 4s. How many 5s? Just 1 5, I think, right? If I'm not mistaken. So 1 5, and then how many 7s? We have like 4 7s. 4 7s. And then 1 8. Sorry, no, 2 8s. Sorry. So 2 8s right here. 2 8s, and then next number or value would be 10, then 13, and then 15. All right. So how many? Just to make sure that I didn't miss anything. 1 2 3 4 5 6 7 8 9. Yes, 9 times 2, that will be 18. Perfect. Okay. So I just ordered my data values. Step number 2. I'm gonna compute the. So we said as a step number in the step number 2, we are supposed to compute 5% of the size of the sample, right? So what's the size of the sample? Size of the sample, that's just the number of data values, right? So the size of the sample, size of the sample. So we have 18 numbers or 18 data values. So the size of the sample is just 18. Okay, that's again, the number of the data values. Okay, now I need to compute 5% of the data values. Sorry, the 5% of the size of the sample, right? 5% of the size of the sample. So what will be 5%? Again, guys, when I say 5%, it's just 5 over 100. All right, so now we compute 5% of the size of the sample. % of the size. So that will be 5% times 18. So we multiply the percentage. So you have to multiply the percentage by the size of the sample. So that's 5% times 18. So 5% is just 5 over 100 times 18. Okay. You can, of course, you can just use your calculator. So this is 5, to multiply a fraction by a whole number. So this 18, it's actually, you can make this 18 look like a fraction if you divide by 1. So like 18, 18 divided by 1, it's again 18, right? It doesn't change anything. Now, this is like just a multiplication of fractions, right? So you multiply like the 5 by 18. So you multiply straight across like 5 by 18 over the 100 times 1, right? So, 5 times 18, that's 90 over, 100 times 1, of course, it's just 100. All right, so 90 over 100, you just use your calculator. This is just 0.9. Okay. Now, guys, you need to round this number, this decimal, to the nearest whole number. Okay, so we have to round to the nearest integer or whole number. So what will be the nearest whole number to 0.9? Any guess?
1.
1, of course, thank you. Thank you. So yes, absolutely. So the nearest whole number is going to be 1. So what we need to do, guys, we need to remove one data value from the top and from the bottom of our data values. Okay, so we have to remove. Let me just write it down here. So we have to remove 1 because it's 1 because the answer here is it's 1, right? So we have to remove 1 data value like from the top and also from the bottom. Okay, so I need to remove 1 data value from the top. So the largest data value, of course, it's 15, right? So I need to remove 1 data value from the top. So I need to remove the 15. Okay, and I need to remove 1 data value from the bottom. So here, the smallest data value is 2, right? So I need to remove the 2 here. Okay, so 1 number from the top and 1 number from the bottom. All right. If your answer, for example, if you your nearest whole number, for example, it's, let's say this number here, instead of 1, let's say you got 3, okay, for some reason. So then we have to remove like 3 numbers, like from the top, and 3 numbers from the bottom of your list or of your data values. Okay.
Question.
Yes, please.
So why did you choose 2 and 15? Why didn't you choose like 2 and 7 or 5 and 15 from top and bottom?
No, the 15, it's like, because that's the top, because that's like the largest number. So you remove one number from the largest numbers. Okay. The 15, it's because it's the largest number.
Oh, so you take one largest number and one smallest
yes,
number?
one largest
Okay.
number, and yeah, one of the largest number. Yeah, one largest number and one smallest number. Yes.
Okay, thank you.
Mm-hmm.
So was the number on top should be like the smallest, and the one in the bottom should be like the largest number.
Yeah, and then, yeah. Mm-hmm. Yeah, that's what I'm saying. Yeah, exactly. Yeah. So that's why I ordered my data values. That's the reason why I ordered my data values. So I know exactly which number would be like in the top and which number would be like in the bottom of the data values in some sense. So yeah, but here we have just one number. So I have to remove the largest number and the smallest number. Let me just, so here, this is supposed to be 1, right? And this is, so we have to keep, of course, the 10 and 13. We only remove the 15 because that's the largest number. And we have to remove just 1, 2. So I'm gonna just erase this thing here I did right here. So I need to keep the 2 right here and the 2 right here. Okay. Any other question, guys? Okay, perfect. So now I can, so this is my new data values, right? So once you remove, like I removed the 15 and the 2, now I got my new data values, or the data values left after trimming like the percentage of the smallest and largest values. So so now I'm supposed to compute the mean. So in the last step, so I'm supposed to compute the mean of the data values left after removing, compute the mean of the new data set. So again, what I mean by the new data set is the data set after removing, you know, the 5% of the largest and smallest numbers. So of the new data set. Okay. Well, we know how to compute the mean. So it should be now. So the mean, the trimmed mean. So first we need to compute the sum. So the sum of the x's. So then we're gonna have 2 plus 2, and then plus 3, right? So plus 3, and then you know, plus 3, another 3, etc. Plus 3, plus, etc. And then so the last number, it's not 15. The last number in the new data set would be 13, right? So plus 13. Okay. Again, because I removed the 15 and I removed 1, 2, right? The first data value. So so this sum here should be equal, I think, to so this should be equal to 94. So this new sum here, this is 94. And so the trend mean would be, so the answer here, so the trend mean, so it's gonna be the sum of the data values over, of course, the size of the sample over n. So that's 94. Now, I need to divide by the size of this new sample, right? I removed two numbers, right? The size of the sample was 18. I removed two numbers. So now the size of the new sample is 16, right? So we need to divide by 16. So be careful, guys, here. So we need to divide by 16. So this is the size of the new sample. All right. And the answer would be, so the trend mean would be, I think, 5.9. I think it's 5.9. So 5.9. Any question, guys, about the trend mean? Nope. Okay, perfect. So let's do an exercise then. Exercise. Okay, so let's say you have the following data set. So the following data set represents the data set represents the weight, let's say in ounces, represents the weight in, let's say, ounces of, let's see, what's that? Yeah, the sample of oranges. Okay. So let's see the weight of the oranges. So first orange, the weight of the first orange is, so we have the following data set. So we have like, let's see. Okay. So we have 4 ounces. We have like 2, 1, 1, 3, again, 2. We have 4, 1, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's say 3 here, 3, 2, 6, 5, 1, 1. And then 0. Oh, sorry, not 0. The weight cannot be 0 here. And then 2 again, 2, and then the last two values. So we have, or last 2 values. So we have 7 here, and then what else? Yeah, we have 10. Okay. All right. So the question now is to compute the trend mean of these oranges. So question. Compute the trend mean after using, let's say, the trend mean using 5% as percentage. All right, guys, I'm going to give you, let's say, a couple of minutes to think about this exercise. So, did anyone get the answer?
Almost there.
Okay.
I got something.
What's the answer?
Is it 2.7?
Yes, yes, very good. Very good. All right. Okay, so yeah. Does anyone need more time? All right, so let's do this. Yeah, so as a first step, so we need to order the data values. So the smallest number, of course, here would be a 1, and we have like 6 ones. 1, 2, 3, 4, 5, 6. So 6 ones. 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4 twos. No, actually 5 twos. Threes, I think we have 1, 2, 3. Three threes, and then fours. We have 2 fours, and then 6, 5, 7, and 10. 6, 5, 7, and 10. All right. I think I got 4, 6, 7, 8, 9. Yes, that's 20, right? 20 data values. Yes. Yeah, 20 data values. Okay, very good. So now step number 2. So we have to compute this percentage of the size of the sample. So 5% of the 5% of the size of the sample. Compute the 5% of the size of the sample. So all you have to do is to multiply this 5% by the size of the sample, right? So this is 5% times, and now the size of the sample, as I said, we have 20 data values, so times 20. All right, so 20 again, because we have 20 numbers, so 20 data values, 20 data values. So that will be 5%, as I said, it's just 5 over 100 times the 20, which is a whole number. You can make it look like a fraction by dividing by 1. Okay, and then you multiply straight across. So this is just like 5 times 20, 5 times 20, that will be 100. And 100 times 1, of course, is just 100. So 100 over 100 would be 1. Okay. So here we don't have to round the number because 1, it's a whole number. All right. So we have to remove one number, 1 here, 1 largest, and 1 smallest from the smallest numbers. So 1 largest and smallest number. Right, so largest number is 10, so we need to remove the 10. And the smallest number is 1, so we have to remove 1. Just 1, of course, 1, all right? 1 data, I mean, yeah, 1. Okay, now I can compute my trim mean, and all I have to do is just to compute the mean of the new data set. So this is, so trim mean So now I have like 5 ones. So 5 ones. So that'll be like 1 plus 1 plus 1, plus 1, plus 1, 5 times. I have like 5 2s, 3 3s, 2 4s, plus 1 6, plus 1 5, plus 1 7, right? Not the 10, of course, because it's removed. Now, so just use a calculator, of course, and I think if I'm not mistaken, this is going to be equal to 50. Okay, this whole sum here would be 50. So that's like the sum of my data values. Now, all I have to do is so the trim mean would be equal to trim mean be equal to the sum of the variables, the data values, over the size of the sample. And so it's 50 over, excuse me?
18.
18, thank you. Absolutely. This is the size of the new sample. And that would be 2 point, as you said, that would be 2.7 or 2.77, I think. So yeah, this 18, this is the size of the new sample. Because we removed 2 numbers. We got rid of 2 numbers, so we are left with 18 numbers, right? Size of the new sample. All right, any question, guys? So that's the trim mean. All right, so if there are no questions, then we can move to the last type of average, the weighted average. So this weighted average is actually the average that I use, for example, to compute your course grade. So this is very, very useful average, actually. So the last type of average is the weighted. So now we have the weighted number 5. So we have the mode, the median, the mean, the trim mean, and now we have the weighted average. So as I said, this is very useful. I actually use it to compute the course grade. Compute, for example, the course grade. Okay, so the idea here is that some values in the data set are given more importance than others. For example, like in our course, for example, if you take the homework, let's say it's 25, it's worth 25% of the final grade, right? But the final, your score in the final, it's worth 35% of the final grade of your course grade, right? So in other words, your score in the final, it's more important than your grade in the homework, right? Because what we are saying is that your final, it's more important than your homework in some sense, right? So because it's given a higher weight. Okay, so yeah, so the idea is that some values in the data set, so some values in the data set are given in the data set are given more importance than others. And so example, so let's say you want to compute your grade in, so you want to compute, so we want to compute the grade, the course grade in, let's say in this course, 23. Okay. So your homework, let's say you got in the homeworks 80%. Okay, so homeworks. So let's say so homeworks are, let's say, worth 30%. Okay, so 30%, that's the weight of the homeworks. So this is the 30%, that's like the weight of the homeworks. Okay, then let's say the midterm, let's say the midterm is 30%. It's worth, or 35%, let's say 35%. Okay, so then this 35%, that's the weight of the midterm. This is the weight of the midterm. Right, and finally, I say the final is also 35%. Okay, so anyway, so the 30%, 35% are just they are weights. So this is the weight of the final. So in this case, for example, midterm and final, they are more important than homeworks, right? Because both are worth 35%. That's more than 30%, of course, right? So that the idea is, as you can see, so your grade in the midterm or the final is more important than your grade in the homework, because the weight of the midterm and the final, it's 35% compared to 30%, which is the weight of the homework, right? So that's the idea here. Now, let's say, for example, you got, so your data set or your data values, so let's say you got 80% in the homework. Let's say you're a very good student, all right? So you got 85% in the midterm, and let's say, for example, in the final, you did really well in the final, and you got 90%. Okay, so the 80% here, the 80%, 85, and 90, they are not the weights. They are just the variables. They are your data values. So that's the score. I mean, that's your score in the homework or the midterm. So this is just the 80, the 85, and 90%. They are just your variables or data values. So these are your data values. I mean, your score in the midterm and the final and homework, right? Now, I want to compute, of course, the course grade, right? So how do we compute the course grade? So we're going to use the weighted average. So to compute the course grade, we use the weighted average. The weighted average. So what's the formula for the weighted average? So the formula is the following. So this weighted average so it's supposed to be the sum of your data values times their weight. So you need to multiply each data value by its corresponding weight over the sum of the weights. Okay, so the W here, this is the weight, right? And the X is just your data value. Okay, so for example, in the homework, you got 80% in the homework. So the 80%, that's your data value. That's your score in the homework. So this is X. Okay, this is X. Now, what's the weight of the homeworks? Well, the homeworks are worth 30%, right? So the weight of this 80% is 30%, right? That's the weight of the homeworks, right? So 30, the weight. So for the homeworks are worth 30%, right? The midterm, so this is 85%, that's your score in the midterm, so that's like your data value. But the weight of the midterm is 35%, right? And the same for the final, the weight is also 35%. All right, so the 35%, that's what I call the W, the weight, right? That's your W. All right, so let's use the formula. So it says like sum of X times W. So for the homework, let's start with the homework. The data value, your score in the homework is 80%, right? So that would be 80%. So 80%, that's your like X. So this is like X. That's your data value times its weight. So what's the weight of the homework? It's 30%, right? So multiply by 30%. So multiplied by 30%. All right, so this 30%, that's the weight of the homeworks. So this is W. Okay, makes sense, guys? So this is for the homeworks. Plus, now what about the midterm? So next, data value, the midterm. So I got 85% in the, you got 85% in the midterm, right? So this 85% would be the data value. That's your score. So this is your X times the weight of 85%. That's the midterm. The weight it's 35%. So times 35%. Right? Plus now the final, your score in the final, your data value in the final, it's 90% times the weight of the final, which is again 35%. Okay, so this is W, this is your data value, and this is the weight of the homework. So you see the difference, guys, between the weight and the data value. So your score in the exam, that's your data value. Then the weight of the exam, that's the like the 30 or 35%, etc. Right? Okay. Now all you have to do, of course, is just to compute this thing here, right here. So this would be, as I said, 80%. You can write it like 80 over 100 if you wanna use if you wanna use fractions. If you don't wanna use fraction, then I mean we can use fractions, of course. But 80%, 80%. As I said, this is just 80 over 100, or you can say, well, 80 over 100. That's just 0.8. All right. In other words, I mean, you can use a fraction or just a decimal. I mean, it's better in this case just to use decimal. So 80%, that's 0.8. So this would be like 0.8, right, times 30%, same thing. So it's going to be 0.3, right, plus, 85%, that would be 0.85 times the 35%, that's 0.35. 90%, that's 0.9 times 0.35. Okay. Any questions so far, guys? All right. I'm probably gonna just erase this thing right here. Yes, so 0.8 times 0.3, that would be 0.024, I think. Plus, let me just see I think I did it somewhere. Plus, yeah, 0.85 times the 0.35. So that'll be equal to, of course, sorry, here it's, sorry, this is 0.29, I think 75 or something, plus, so this is actually 0.8, of course, times, this is 0.24. I don't know why I had another an extra 0 here. So this is just, of course, 0.24 right here. Okay. And finally, 0.9, of course, times this, 0.35, that will be equal to, this is just equal to 0.315. All right. Now the total would be, so plus 0.29 plus 0.24. I think, if I'm not mistaken, this is this should be 0.84 or 85. I think it's 85. Okay. So 0.85. Now, so that's like the top of the formula, right? So the top, as you can see, in the formula of the weighted average, we have the sum of x times the w, the data value times the weight. And in the denominator, we have the sum of the weights. So the weight of the homeworks is 30%. The weights of the, so let's do the denominator, the sum of the weights. So the weight of the homeworks is 30%. All right, 30%. The weight of the midterm is 35, plus the weight of the final, it's also 35%. So as I said, 30%, it's just 0.3 or 30 over 100. I mean, this is 35 over 100 plus 35 over 100. If you want to use decimals, this is just 0.3 plus 0.35 plus 0.35. All right. Anyway, so the total here, that will be, of course, 1. So it's equal to 1. The sum of the weights, it's equal to 1. So what will be your course grade? Well, your course grade, your weighted average. So then the weighted average, your course grade, weighted average. So it's going to be equal to the sum of the x times the weight over the sum of the weights. So the top, we said it's 0.85. And the denominator, the sum is just 1. Okay. So this is just 0.85. Okay. So what we are saying here, guys, is that your course grade is going to be 0.85. In other words, this is 85 over 100. Or if you would prefer percentage, this is 85%. Okay, so that would be probably a B. As a letter, a grade, that would be probably B or B plus if you have a nice instructor. Okay. Any question, guys? All right, so, okay, here's an exercise for the weighted average. Exercise. All right, so, yeah, just find the weighted average of a data set where let's say the first data set is 10. and 10 actually has a weight of 5. Second data set, it's 20. And let's say 20 has a weight of, let's say 3. And finally, last data value is 30. And let's say 30 has a weight of 2. Okay, so what I'm saying here, guys, so your data values or your data set is just 10, 20, and 30. So this is your data values. The 5, 3, and 2, of course, that's the corresponding weights. Okay. Okay, well, you have like 2 minutes to think about this exercise. But anyway, the idea, of course, is to, so the formula for the weighted average is this one here. The sum of the data values times the corresponding weight over the sum, the total sum of the weights. Yeah, I mean, with this exercise, we are done with this section 3.1. So next time we can start section 3.2. So again, this section, we have seen like different types of averages, the mode, median, the mean, the trimmed mean, and finally this weighted average. All right, guys, I mean, we have like 1 minute to go over, so I can go over this exercise. I mean, yeah, you want to find the weighted average, right? So like in first step, you need to compute in step 1, you need to compute like the sum of the data values times the corresponding weight, right? So first data value, of course, is 10. That's my first data value. And the corresponding weight, what's the corresponding weight of 10? It's 5, right? So that's like 10 times 5 plus second data value is 20. Corresponding weight, it's 3. Last data value is 30 times corresponding weight, which is 2. So here's the sum here. This is 50. This, of course, this is multiplication right here. 50 plus 60 plus 60. So this sum here, that will be equal to 170. Okay. Second step, we need the sum of the weights. Right, sum of the weights. So first weight, it's 5. Second weight, it's 3. And last weight, it's 2. So the sum of the weights, it's 10. Now, all you have to do is just to divide. So step 3, we divide the x times w. So the answer, the weighted average. So that will be the sum of this x times w, the data value times the corresponding weight over the sum of the weights. So that will be 170 over 10, which is, of course, 17. So the 17 would be your weighted average. All right. So in this data set, of course, the most important value, of course, is the 10 because its weight, it's 5. Okay, which is larger than 3 and 2. Okay, so the most important data value in this example would be the 10, right? That's so 10 here is given more importance than in the 20 and the 30. Okay, because it has the largest weight. All right, guys, thank you for listening. So I'm gonna stop here. We are done with this section. So I will see you hopefully next this Wednesday in person. And so please don't forget your homework number 2. All right, guys. Thank you for listening, and see you next time. Thank you.
So you're gonna post this lecture?
Bye.
Excuse me?
I'm asking if you're gonna post this this lecture.
Oh,
on-
yeah. I'm gonna upload it. Yeah, sure. As usual. Tomorrow morning you will find it on YouTube. Yes.
Did you check the attendance, mister?
Yes, I did. Who's talking?
Kathleen.
Kathleen. Okay, thank you, Kathleen. I got you. Thank you.
Thank you.